So please introduce yourself.
Yeah, hi, my name is Rob McManus. I'm a Principal Product Marketing Manager here at Red Hat.
And I hear you're doing something new. Your new announcement, you're talking about optimizing the 5G and ARM
Yep, that's
devices.
right. So this week we've made an announcement. It's to do with our collaboration with ARM. It's in the context of telecommunications, specifically around enterprise or private 5G. And the collaboration is really around trying to address huge energy costs that we see from service provider networks, and predominantly the biggest energy costs come from what we call the radio access network. So really our collaboration with ARM is there to sort of go and sort of see what we can do in terms of reducing energy, because we know that's a big problem for service providers. And we want to try and really make the infrastructure more sustainable. But when we do all of these efficiency measures, we do have to be very mindful of performance, because we know in these environments, these networks have to highly perform, they have to deliver exceptional bandwidth, and they also have to deliver very low latencies. So in a moment, I'll show you an architecture diagram, but it's essentially the work we've done with ARM is really integrating what they call their neoverse-based CPU into the Red Hat OpenShift container platform, which is essentially an application platform that service provider network functions can use in a radio access network environment. And then in terms of benefits, it's about, as I mentioned, energy efficiency. It's also about giving service providers the ability to build very flexible networks. It's allowing them to deploy these networks at scale in a very sustainable manner. But again, just coming back to this really important point at the bottom, it's to ensure performance as well as efficiency. So let's look at the architecture.
So you're talking 40% better price performance.
Yeah, that's
huge,
right.
Because everybody wants to be connected, and it's too many people who want to do too much internet, too much 5G. We need to find a solution. Let's do ARM.
We do. And that demand is only ever increasing all the time. So service providers are really looking to the vendors and the software manufacturers to come up with innovative ways to address this surging demand and to make their networks as energy efficient as possible. So in terms of our collaboration with ARM, we can see here the initial work that we've done. So there's a server, you can see at the bottom there. The ARM processor, in this case the Ultra CPU, is then fully integrated into the Red Hat OpenShift container platform. So the Red Hat platform is essentially an application platform, application being the key word here, which has the ability to integrate different applications, in this case from a partner that we've also working with here called FNet. So you can see here something called a CU or centralized unit, and also a DU or distributed unit. So both of these are used in Open RAN or virtualized or Cloud RAN networks, and we've also integrated the core. So with all of these components, this actually creates an end-to-end 5G network. And you can see over on the right-hand side as well, another partner involved in the collaboration, Benatel, they actually provide what we call the RU or the radio unit. But think of it as an end-to-end, fully sort of package solution for radio access networks.
What's happening over there? How is it different from what you've been doing before?
Really no different, in the sense that the OpenShift is this layer, this application platform or layer that allows different applications from different partners that we collaborate with to put their functions into OpenShift. So the key difference is down at the bottom here, where we've worked with ARM to use their processor and their essentially very efficient architectures to really deliver better efficiency, but not at the price of performance within this environment.
This Ampere CPU sounds pretty awesome. 80 core, sounds like it
very powerful.
Can do a lot of stuff.
Very powerful, yeah. I mean, this is just one context. There'll be other applications that we could use this for example, in the 5G core. So not shown here, but the 5G core itself has to sit on some form of infrastructure. So within that environment for 5G core, we could also use ARM CPUs again to get the same efficiency gains.
All the stuff Red Hat has been doing with ARM servers in the previous years. So this is like next level stuff.
It's just an ongoing collaboration where it really comes down to choice for our customers, which essentially are the telco service providers. So they want choice, they want the flexibility to go and work with the partners that they want to work with. And Red Hat is essentially the same. Red Hat mantra is open source, of course, and we always say customer first, partner always. That's another one of our mantras. So that's the key to this. It's about flexibility, freedom of choice, and making sure that all of these applications, processors, platforms, and everything else that's involved in the solution all work. Because at the end of the day, this actually adds a little bit of complexity. With these types of collaborations, we can ensure that all of that complexity is simplified and we integrate and make these solutions fully interoperable.
As I understand, 5G is a lot to do with many more base stations.
That's
and
right.
You want to have closer base stations to all the people. So that means ARM is a perfect solution because you don't necessarily want to do as big base stations as before, as powerful, or maybe you could.
You could, but you're absolutely right.
You might want to save power, that's the most important.
You're absolutely right. So 5G tends to deliver very high bandwidths, but you have to get the equipment closer to the end users. So what you're seeing in a lot of networks is what we call disaggregation. So everything's being broken into smaller parts, and those smaller parts can then be put in different places within the network. So in this particular picture, we can come back to this. A 5G core would typically be in a central location, but the things like the distributed unit, and very much so the radio unit, will be in very distributed locations, really close to the edge of the network. And that's important in 5G, really, to ensure good performance, but extreme low latency as well. You have to get as close to the edge of the network as you can.
Nice, and hopefully no drop frames when I live stream. That's a joke. So, do you want to talk about some more in that presentation, or that's most of it?
No, that's most of it. So let's just give you a few key takeaways. So, really, the collaboration with ARM and the other partners that are mentioned here in the slide, it's really about deploying sustainable private 5G or enterprise 5G networks that you can see here. And the main, or the key benefits that come out of a collaboration like this is essentially lower total cost of ownership, or TCO. It's about reducing that energy, but also reducing the complexity, and as we've discussed, really meeting this exponential demand that we see all the time, only ever increases. So those are the key takeaways.
Nice, awesome, thanks a lot. So
does that work?
And customers hopefully are going to say, this totally works. Let's go 100% into the ARM world. That's what I'm hoping.
Let's hope so. But again, it comes back to choice. What we want to do is give customers choice and the flexibility. If they want to use ARM, then we've done all of the interoperability testing and make sure that it all works together, so that it can come to somebody like Red Hat and we're ready to hit the road.
Cool. All right. Thanks a lot. It's a good Mobile World Congress.
Yeah, very good and very busy. Lots of meetings. So yeah, it's been a good 2 days so far.
Thanks a lot. Thank you.
Okay.
Cool. All right.